For 40 years, Uranus has been the black sheep of our solar system in the every astronomy textbook printed since the late 1980s. The Uranus is described as a bizarre outlier, a planet with a magnetic field so weird and broken that it defied almost everything we knew about the planetary physics. When NASA's Voyager 2 spacecraft screamed past the ice giant in the year 1986, it sent back the data that flummoxed the scientist. It depicted a magnetosphere, that protective magnetic bubble around a planet that was almost completely empty of plasma, yet filled with radiation belt so intense they were second only to Jupiter's. It didn't make any sense. There was no plasma. Where was the radiation coming from? And why were Uranus moon, which should have been spewing out ions like the moons of Saturn and Jupiter, seemingly dead and inert? Well, as of late 2024 and early 2026, we finally have the answer. It turns out Uranus isn't a misfit at all. We just caught it on a very, very bad day. Today we are diving into the supercharged mystery of Uranus, the cosmic coincidence that fooled NASA for 4 decades, and why this discovery changed everything we thought we knew about the search for life in the outer solar system. To understand the solution, we first have to understand the crime scene. In January 1986, Voyager 2 became the first and so far only spacecraft to visit Uranus. Because Uranus is nearly 2 billion miles away, the flyby was incredibly brief. Voyager didn't orbit the planet, it zipped past at the speed of 45,000 miles per hour. Scientists had just a few days to gather all the data, and they would have for next 40 years. What they saw was baffling. First, the magnetic field was tilted at a staggering 59 degrees away from the planetary axis of rotation. Not only that, but the field didn't even start at the planet's center. It was offset by about a third of the planet radius. But the biggest mystery was the vacuum magnetosphere. Usually, a planet's magnetic bubble is filled with plasma, charged particle from sun or the planet's own moon. But Uranus' bubble was nearly empty. Yet, strangely, it had these massive belts of high-energy electrons. For 40 years, scientific community struggled to explain this. Theories ranged from internal dynamos to ideas that Uranus was simply a unique and different freak of nature. We assumed its moons like Titania and Oberon were geologically dead because we didn't see any of those water ions that should have been pumping into the space. Fast forward to the recent years, researchers led by Jamie Jasinski at NASA's Jet Propulsion Laboratory decided to take another look at that 40-year-old data sheet. But they didn't just look at the flyby itself, they looked at the space weather in the days which led up to that. They discovered that just before Voyager 2 arrived, a massive rare solar wind event had slammed into Uranus. Think of the solar wind like a stream of water from the garden hose. Usually it's a steady flow, but occasionally the sun let out a gust, a high pressure stream of plasma. New analysis shows that the Voyager 2 arrived during a 1 in a million cosmic coincidence. An intense solar storm had compressed Uranus' magnetosphere to just 20% of its normal volume. Imagine taking a balloon and squeezing it with both hands until a tiny fraction of its size. That is exactly what the sun did to Uranus. This supercharged solar wind crushed the magnetic bubble, squishing the plasma out of the system and injecting high energy electron into the radiation belts. If the Voyager 2 had arrived just 5 days earlier, the textbook would have written entirely different story. This discovery is a eureka moment because it fixes the broken model of Uranus. Scientists now believe that under normal conditions, Uranus' magnetosphere is just as normal as Jupiter or Saturn. This means the planet isn't an outlier. It follows the same rules as its giant neighbors. But the most exciting part is the moons. For 40 years, we thought Titania and Oberon were frozen dead rocks. Why? Because Voyager didn't see any water ion around them. But now we know the solar storm likely stripped those ions away or pushed them out of the view just as the camera was rolling in. They reopened the door for something incredible, which is subsurface oceans. If these moons were actually spewing ions into a normal magnetosphere, it suggests they are geologically active. And where there is geological activity of water ice, there is a very high probability of liquid water oceans hidden beneath the surface. Suddenly, Uranus isn't just a cold, lonely gas giant, it's a system of potentially habitable worlds. This discovery highlights a major problem in space exploration, which is the snapshot bias. We have based our entire understanding of a planet on a single 2-day window from 1986. It's like looking at a photo of the city during a hurricane and concluding that the city is always underwater. The scientific community is now pushing harder than ever for a dedicated mission, the Uranus orbiter and a probe in future. We need to see Uranus on a normal day. We need to see the magnetosphere breathe, watch its auroras, and taste the particles coming from its moon to see if they really do contain the chemical signature of life. NASA's decadal survey has already listed a Uranus mission as a top priority for the next decade. With this new data, the mystery of Uranus has transformed from a physics headache into a biological treasure hunt. So the mystery is finally solved. Uranus wasn't weird, it was just unlucky. It took us 40 years to realize that our only close-up look-up at the giant was a fluke of timing. And that's the beauty of science. The data never changes, but our ability to understand does. We are finally stripping away the weirdness of the seventh planet and seeing it for what it truly is, a dynamic, complex world that might be far from more alive than we ever dared to dream. So next time when you look up at your textbook and see those strange 1986 diagrams of Uranus' magnetic field, remember, you're looking at a planet during a storm. The real Uranus is still waiting to be discovered. So friends, what do you think? Should Uranus be our next big destination after Mars? Let me know your comments below. And don't forget to like and subscribe and hit that bell to stay updated on the latest discovery from across the cosmos. Thank you for watching, and I will catch you again in the next one.